Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the calculations of dS for ideal gas. Clausius realized in 1865 that he had discovered a new thermodynamic property, and he chosen to name this property entropy. It is designated as and is defined as. Entropy is an intensive property of a system and sometimes is referred to as total entropy. Entropy per unit mass designated as is an intensive property and has a unit kilojoule per kilogram Kelvin. The term entropy is generally used to refer to both total entropy and entropy per unit mass, since the context usually clarifies which one is meant. Recording the first law for a reversible process, we have the entropy change. For an ideal gas, the equation of state is. The entropy change for a reversible process can be expressed as. I have one question for you. Are the relations of the entropy change only available for reversible process? Since the entropy is an intensive property and depends only on the state, the entropy change between two specified states is the same whether the process is reversible or irreversible. Therefore, the relations of the entropy change are available for an ideal gas proceeding any reversible process. 1. The entropy change can be calculated with fixed specific heats. The entropy change from states 1 to 2 can be evaluated with fixed specific heats. 2. The entropy change can also be calculated with the specific heats, which are functions of temperature. When the reference temperature of 0 Kelvin is chosen, the absolute entropy is obtained. The absolute entropy for air is shown in Appendix A9. We can also find in the appendix for other gas. The entropy change can then be determined from the absolute entropy. Can you find the differences between S0 and SM0? Here are some commands for the calculations of entropy change for the ideal gas. Since the average specific heat table and the gas property table are all compiled based on the process numerical value of the specific heat, the most reliable results can be obtained. Compared with them, the relative area calculated by the true specific heat capacity is about 1%. The straight line formula is an approximate formula with slight errors. The error is not large within a certain temperature range, and it has sufficient accuracy. The fixed specific heat is an approximate calculation with large errors, but due to its simplicity, when the calculation accuracy is not high, or the gas temperature is not too high, and the change range is not large enough, the entropy change can generally be calculated according to the fixed specific heats. Okay, that's all for this task. Thank you very much, and see you next time.